In this video, we're going to look at how to use our Casio graphing calculator to graph some basic functions, find roots, intersections, intercepts, and maximum and minimum values. These are some of the more common basic functions that you'll be using your graphing calculator for in your course. So again, this is not an all-inclusive video that will explain everything, and if you have a different model other than the simulator that I'm using here, there might be slight differences. So let's start with something basic. Let's look at this function here, y equals 2x plus 1. Go ahead and draw a graph from it. The way you're going to start is you're going to choose menu. You're going to go across over here to choose graph and exit. So graph function. Our first function we want to graph is 2x plus 1. Remember to use this button here under the red alpha button to input your x variable. Execute, and we're ready to go. To draw the function, if you look across the bottom, you'll see draws here above the F6 button. So we're going to choose F6, and there is a picture of our graph. Now, there are several bits of information that we would like to know about this graph that we can get. So we're going to use Shift, and then here you see GSOLV, which stands for graph solve. So we're going to press F5. It's going to give us a menu of choices of things that we can find. We can find the roots, which of course for a linear equation would be the x-intercept. And here you can see the x-intercept is negative 0.5. Other things for a line that we would be interested in is the y-intercept. So that's right here, the y-intercept. I'll choose S4, F4, and you can see here that the y-intercept is at 0, 1. Which is what we would expect as our equation is in y equals mx plus c form. So we would expect the y-intercept to be 1. So let's go ahead and add a second equation. Here's the other line. I'm going to draw a graph of y equals 3 minus x. So we've gone up here, we've gone to a second function. As you can see, we can input several functions. 3 minus x, and I go up here to draw. And as you can see, I now have my second line drawn. Once again, Shift G solve will allow me to find the different points of interest. We can find the roots. Perhaps this time we want to find the y-intercept. So y-intercept, again, I now have two functions, so I need to select which function I would like the y-intercept for. In the upper left-hand corner of the window, right now I have the first function, 2x plus 1. Simply press the down arrow, and now I'm looking at the second function, 3 minus x. So this is the function that I want to solve. I want to know what the y-intercept is. And you can see the y-intercept is, oh, I've mistakenly put in the first function again. So I think I've gone back one too many. I want to solve this. I want the y-intercept. I don't want the first function. I want the second function. And you can see the y-intercept is 3. Now, of course, another point of interest to us would be, where do these two lines intersect? And as you can see in my graph solve here, one of my choices is ISCT, which is the abbreviation for intersect. So I'm going to choose that one. You can see now that both lines, both functions are shown in the upper left because those are the two I'm finding the intersection of. You can see my x-coordinate, y equals 0.6 recurring, and the y-coordinate of the intersection is 2.3 recurring. So this is what I can do when graphing straight lines. Again, I can add several straight lines to see what happens. All right, let's clear these functions out. Here we can delete. Yes. And let's delete my other function. And let's start with a new function this time. Okay, here's a new function. Let's graph a quadratic this time. So I'm going to graph x squared minus x minus 30. And I'm going to draw. And you notice I don't see anything. Does that mean I've made a mistake? Well, maybe I've made a mistake when I put it in, but more than likely my viewing window is not set to the right scale for the function, and that's why I can't see the function. So here above the F3 key is V window, so Shift view window, and it allows me to change the parameters of the window that I'm viewing. So let's open it up a little bit. Let's make x go from -8 to 8, and let's go down and make the y minimum -35, and let's see if that works for us. So let's try drawing it again, and there. Now we've changed the view window, and now we can actually see our graph. So if we want to find our points of interest, again, graph solve. Over here I can find my roots. You can see my root is -5, 0, and my other root over here on the right is x equals 6. Other things of interest, we can see from the graph that we have a minimum point. If we wanted to know what the minimum point was, right here F3 under minimum, and it tells me my minimum point x is 0.5, my y is -30.25. The other point of interest to us here would be the y-intercept, and my y-intercept is x equals 0 and -30. So we can very quickly find the points of interest for our quadratic equation or our quadratic function. Here's another quadratic function that we want to go ahead and solve. So now we have some different options this time. We could rearrange this equation, bring the 10 over to the left-hand side, so our quadratic equation equals 0, which is what we're used to doing, and we could then plot the function x squared minus x minus 10 equals 0 to solve it. The other thing we could do, taking advantage of our graphing calculator, is simply plot the function on the left as one function, plot the function on the right as a second function, and to solve this quadratic equation, we simply find the intersections. So let's go ahead and try that. So our first function will be x squared minus x, and our second function is just simply y equals 10. So we go ahead and draw that, and we can see that we have a quadratic intersects a line. Now, if our aim was to find the solution to this quadratic equation, we solve it, and the solution is going to be where these two functions, the quadratic and the line, intersect. So we're going to choose the intersection, and we see here one intersection is at -2.7 approximately, and and that's our one solution to our equation, and the other solution to our equation is x equals roughly 3.7. So this is another way. Of course, the other option would have been to bring the 10 over to the left, plot the single function x squared minus x minus 10 equals 0, and go ahead and find the roots using the graph solve to find the solution to that problem. So I'd like to look at one more example here. Let's expand our scope here and plot a cubic equation and a linear equation and just explore the functions that we can do. So our first one is going to be x cubed minus x squared minus 2x. That will be our cubic function, and we will plot a linear function x minus 2. Now, if we go ahead and draw those, we can see we have a cubic and a line, and we can see that they intersect at several places. Another option of changing your viewing window to help see things rather than changing the viewing window is you can always zoom. And so if we want to zoom in, we simply put the cursor where we want to zoom in, put it maybe roughly in the middle of our field, and as you can see, it very quickly changes the scale and we've zoomed in. So we can see that our line crosses our cubic equation in 3 spots. So we can explore with our graph solve. Again, we could find the roots, and of course, of more interest, harder to find would be the roots of the cubic equation. So I'm going to select the cubic equation. So there's one root there where x is -1. Use my arrow key. There's another root where x equals 0. And the third root is x equals 2. We might be interested in finding the y-intercept of either of them. Let's find the y-intercept of the cubic. And we can see the y-intercept is x equals 0, y equals 0. So the other thing that would be of interest is the intersection between the cubic, and the line. So again, we're going to choose ISCT, which is the abbreviation for intersection, and it gives us our first intersection there. We can see the bottom of the screen. We can see the coordinates of the intersection point. Use the arrow key. There's my second intersection point where x is approximately 0.6 and y is approximately negative 1.38. And one more, and there's my third intersection, x equals 2 and y equals 0. So you can see our graphing calculator can become very handy to solve equations, especially when they get beyond quadratics, when it's not as easy to solve them algebraically. So I highly recommend practicing regularly with your graphing calculator. This is the only tool you're allowed to have with you during your exam. So while doing your work at home, it might be easier to use your laptop to go ahead and plot your graphs. A bigger screen with lots of colors, you do need to practice, because this is the only tool you'll have to be doing your graphs during your exam. Use it, practice with it regularly, and best of luck.